Hi, welcome to How to Repair. Today I'm going to be showing you how to fit a new heating system to a vented tumble dryer or condenser tumble dryer. I'm also going to be showing you how to replace the pear-shaped bearing that is a phosphorus bronze bearing which is on the back of the machine, and this needs to be replaced really every 4 or 5 years depending on the amount of use you have. In the previous video, I showed you the problems that can occur when fluff buildup occurs throughout the machine. And it is very important to do maintenance on the machine every 4 to 5 years. At the end of this video, there will be a link to that video, which I really do suggest you watch. Not only will it save you a lot of money, it will also prevent fires. I also noticed that when I tested the machine, that the actual machine had been caused to overheat. This caused, I think, the element to blow on one of the circuits because you've got a high and low heat setting on the element, and this is the button here. But when you turn the machine on and start the machine, you can see that the machine is pulling 5.8 amp at the moment. And when I turn it on to either the low or the high setting, it is only drawing 5 amps. This means that the element is not going on to high heat. And we either have a problem with the heating element, which is the most common one to cause the problem, and this was all caused by a fluff buildup in the machine. So we're not only going to inspect the element and rectify the problem, we're also going to do maintenance on the machine. Okay, first thing that needs to be done, unplug the machine from the electricity supply, flat blade screwdriver, and you need to remove the plinth. Then there are a couple of screws here, also on the back of the machine, and also you will need to undo a screw at the bottom. I'll fast forward this for you so you don't actually have to wait. We only need to take the right hand side panel off. The first thing you need to do is unplug the electricity supply. There's normally a cable tie on this, but in the previous video I took the heater off to test it. I'll also test it in this video, but just unplug that. Now we need to remove the screws at the back. Okay, all that needs doing is these 2 screws here, and then the screws that hold all the way round, plus the retention bar. I have already had this panel off before, but sometimes you will need to stick a screwdriver through. In the previous video, it was quite hard for it to come off. Once that comes out, thread the cable through, and there we have the heating element. We'll test that in a second, but the first thing we're going to do is replace the bearing. Now, this wire is normally tight around the bearing, but in the previous video, I took it off to show you how much wear there was. And if you look at the bearing here, while I lift the drum, you can actually see that there's movement in the phosphorus bronze bearing. This means it's worn and we're going to replace it. This wire needs to be straight and then just pull it through. Sometimes it's quite hard to get out. This will either be a Torx 20 or Torx 25. Clean the shaft up because you will have a build-up of muck on it. And the shaft is in perfect condition because the bearing hadn't gone all the way through. If the bearing has gone all the way through, it would actually cut on the metal here. So here's the new bearing, and I'll bring up the old and new so you can see. Drop the new bearing on, lift the drum up, put it in place and replace the screw. A lot of engineers will put grease on or some sort of lubricant. I personally do not. The reason being is, one, phosphorus bronze is designed to be a non-lubricated bearing. Number 2 is, by putting grease on the shaft, the dust that's within the machine is going to stick to it, therefore becoming a grinding compound which will make the bearing wear quicker. So personally, I would not put any grease on it, just put the cap back on, leave it as a dry bearing, and remember to replace it every 4 or 5 years depending on how much usage you have on the machine. Once the actual clip goes all the way through, bend it in the opposite direction so it locks the bearing in place. Now we'll have a look at the heating system. The heater actually comes out with 2 small screws. Do keep them separate. And once we've done this, I'll quickly show you how to test the element and the 2 thermostats. A clip on here that you just need to press, and that pops through. Then you can remove the whole heating element. Right, when handling these elements, be very careful because they are very delicate. The coils are delicate, and you can see fluff that was all over this element, and it's already been hoovered once, so it was a fire problem. But the first thing you want to do is turn your meter to ohms and continuity. Take off the 2 wires going to the thermostats. Now you would think both of these are thermostats, they're not. One is a thermostat, the other is a cutout. Let me explain the difference. The thermostat is a cycling thermostat. When it gets to its correct temperature, which may be 80, 85 degrees, somewhere in that region, it will cycle. This means that it will turn the heater on and turn the heater off. The cutout thermostat is a higher temperature. This means that if it gets to a dangerous temperature, the cutout will not only cut out, it will stay cut out until an engineer or someone has actually found the problem with the machine. In this case, the thermostats had most probably cut out, but the element had actually gone open circuit, which I'll show you in a second. But this was due to fluff buildup in the previous video that I did, which is the link at the end of this video. So quickly, we'll just test the 2 thermostats so I can show you that they both got continuity. Continuity on that one, and we've got continuity on that one. Now the element is slightly different. We have here, and if you can see this on the camera, a link wire in the middle, and we have an orange wire going to it. It may vary in colour from manufacturer to manufacturer, and also the replacement parts are different as well. The new element for this is different colour wiring, but it is configured the same. So this wire in the middle is either called our neutral or common, and this goes to both sides of the heating element. Now if we test the blue going to orange, this has got continuity, and we have 46.7 ohms resistance, which equates to about 1 kilowatt of energy. We should have exactly the same on the other side, but this one is open circuit, meaning no heat. This is why this tumble dryer, not only the real excess fluff problem that occurred with this machine, which caused it to fail, but it also had overheated at some point and possibly burnt the coil out, or the coil just died because of age. But basically it was only heating on half heat. This means that it was taking an awful long time for the clothes to dry. Now if I move this out of the way and bring up the new element, and I'll just quickly, I won't test the thermostats because they're brand new, but I'll just show you the coils. Now as you can see on this one, we have a black, red and white. It's exactly the same. The middle one is the common with the link wire, and as you can see here it's got a black wire, and we'll test this across to the red, and we have 46.7 ohms. This means this field is good, and when we test to the white, we've also got 48 ohms resistance. This means that the element has a combined value of 2 kilowatt, where the old element, which was broken, only had a 1 kilowatt element. This means that this dryer now will dry in a much more efficient time, saving you money and energy. And because we've removed all the fluff as well, that will also save you money and energy. So we'll fit this all back together and we'll test all the machine. Okay, the element just fits in, and as I said, do be careful with it, and just line up the holes, and then you can put the screws in. Lift it up, thread the cable through, as I said, the wiring configuration is different on this one, so the black is going to the orange. That's because we know it's the neutral. That just clips into place. Now you need to put a cable tie on just around this wiring to make sure it's all neat and tidy. This means that nothing can get in the way of the belt. And then I'll just cut these 2 cable ties off a little bit short so they can never interfere. Now we're ready to put the side panel on. Remember, there are some catches when putting the side panel on that locate at the bottom and the panel slides on. You'll notice this machine is immaculate. If you see the previous video, you'll understand why I really spent a lot of time going through the whole machine, making sure that it was completely clean of any dust to prevent fires and also make the machine more efficient. You need to make sure that the support bars go into the correct place, and it goes that way. These were a design change because the original cabinet was a little bit weak, and this stiffens it right up. And there you go, the tumble dryer is all working perfectly again, and it's more efficient and not a fire hazard. I can't emphasize enough to you all, or passing this to anyone who has a vented tumble dryer. It is very important that you understand that fluff buildup can be a potential fire hazard. So let me just show you the ampage meter with the element running. So if I turn it on to heat, now we're pulling 10 amp electricity. This means that the element is 2 kilowatt plus the motor turning, and the machine is quieter as well. When I reduce the machine to half heat, you can see that the element drops down to 5.7 amp. This is what the fault was originally. Even on high and low heat, it would not go above 5 amp. This means that it was not drying efficiently and in the allocated period of time. Thank you very much indeed for watching this video. Always remember, by the way, whenever using a tumble dryer, don't open the door to check if the clothes are dry all the time. Let the machine always do the last 10 minutes of the dry cycle. Because if you look here, and I turn it on to 9 amp, 10 amp, when it goes into the last 10 minutes, the heater turns off. This allows the machine to cool down. This is what it is supposed to do. And if you let this happen every cycle, this will stop you ever blowing any thermostats, because the thermostats sometimes can carry residual heat when the actual motor or the machine is stopped. Now it's safe for me to open the door because there was no heat drawing. This means that the element has had chance to cool down. I hope you enjoyed this video. Remember, there are many videos on the website to assist you. And again, I can't emphasize to watch this video at the end about the actual fluff buildup and everything. There are videos on how to change the capacitor, how to change the front bearings, many more videos on these Hotpoint Indesit tumble dryers. Thank you very much indeed for watching. I hope we helped you. And remember to subscribe to the channel. And if we really helped you, you can always click on the Bipolar Beer page. Thanks again for watching.